Gurubhyo Namaha. I am Anisha from Panvidya Ashram. I welcome you all for this session. Today we are going to learn Chapter 2 Relation and Functions Part 3. Already we have learned what is relation. Now today we are going to learn what is a function. A relation f from a set A to a set B is said to be a function if every element of set A has one and only one image in set B. That is, all the elements of the set A should have one and only one image in B. Then you say is a function. See, I have given you so many examples to check whether it is a function or not. See, the first one, the first set A, it is 1, 2, 3, 4, 5, minus 5. Set B, it is 1, 4, 9, 16, 25. So, all the elements is related to B, is it? And every element has only one image. That is, if see here 5 is having only one image 25, and also minus 5 is having only one image 25. So, the first set is a function. See the second one. The first set A has 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6, 7. See, all the elements of the set, that is 1 to 6, all the elements have one and only one image in B. So, this is also a function. Now, see the third one, this one. Here A, B, C, three elements are there. Right hand side Amit, Bittu, Boli, Don. Now, is it a function? You have to check it. Now, by the definition, all the elements of A should have image. But here C is not having the image. So, this is not a function. Now, see here another one example. Figure 1, figure 2 is given now. F from A to B. That is it a function? The first set has 1, 2, 3, 4. Second set has W, X, Y, Z. You have to check whether it is a function. See whether all the element of A has an image there. Yes, only one image. Now see the second one. 1 and 2 are two elements in A, and in B there are W, X, Y, Z. See, the element 1 is having two images in B, W and X. But by our condition, if a function is said to be, that is, a relation is said to be a function if it should have only one image. But for 1, here it is two images are there. So, it is not a function. Similarly, 2 is also having two images in B. That is Y and Z. But 2 should have only one image. So, this is not a function. I think you are clear about this, what is a function. Now, again, if you want, you can see an example. Here A and B function, a relation is given. The set A is 1, 2, 3, 4 and set B is W and X. Now see, 1 and 2 is related to W. By the definition, what can you say? The element of A should have one image. So 1 is having one image only W. 2 is having also the same image W, but it is 1. So this also is a function. Also here it is explained clearly in the box, that is this whole set is domain and what is related is range. Already I told you. Here for your understanding I have given this. The relation is 1B, 1 is related to B, 5 is related to A and 8 is related to B. Is it a function? All the element of this first 1, 5, 8 is related to here the other A, B, is it? So, it is a function. Here you see 1, 5 and A, B, C. Now, 5 is having two images, A and B. So, it is not a function. By our definition, we should have only one image. Next, what is a real valued function? A function which has either or one of its subsets as its range, then you will say it is a real valued function. A function will be having or one of the subsets. So range should be either the whole relation or the subset, then you will say it is a real valued function. If its domain is also either R or a subset, then you will say as a real function. This word will be using there, that's why it is given. Now there are so many types of function. We will learn one by one. The first one is identity function. What is identity function? So a function f from R to R is defined by f of x equal to x. For each x belongs to R is called an identity function. Now see, suppose if you take f of x equal to x, y equal to x, if you take, suppose I take this f of x as y and this is equal to x. Now if you take some points x equal to 1, y also will become 1. So you will get the ordered pair 1, 1, 2, 2, 0, 0, like that you will be getting. So when you plot the graph, this graph passes through the origin and it will be a straight line. So it is called an identity function. What is the domain and range? The domain and range both will be the set of all real numbers. That is, if you put x1, you will get y also 1, x2, y also 2, 0, even negative values you can write. So when you plot it on this graph, you will be getting a straight line which is passing through the origin. The next is constant function. The function f from R to R defined by f of x equal to k, x belongs to R where k is a constant is called a constant function. That it will be parallel to x axis. That is, for all the values of x, you will be having the same constant. For example, if you take 2 and if I take the constant as 1, suppose some 4, it will be 2, 4, 3, 4, 7, 4. So you will be plotting like this. So this k, if k is a constant, I am taking 4. If you plot 2, 4, 3, 4, 7, 4, so you will be getting a straight line which is parallel to this x axis and it is called the constant function. What is the domain? Domain will be your real numbers and the range will be, that is 2, 3, 4, 5, 6, 7, etc. It belongs to the set of all real numbers. And what is the range which is related to the other number set? That is 2 is related to 4, 3 is related to 4, 7 is related to 4. So your range will be the constant value. That is, whatever constant we are taking, that will be your range. Next is polynomial function. A real valued function is f of x equal to a0 plus a1. You know what is a polynomial function. It is defined as f of x equal to, I learnt in lower classes, a0 plus a1 x plus a2 x square plus etc. an x power n. In general, we will be writing this. Now a0, a1 etc. an belongs to R. Each x belongs to R is called a polynomial function. You know what is a polynomial, is it? So if you are writing in terms of f of x, then you will say it as a polynomial function. And it can be either any of the values, 1 by x, any graph you can plot it. Here the domain is R and the range depends on the f of x. Whatever polynomial is given, the range will differ accordingly. Next is rational function. Now, rational function, these are the real function of the type f of x by g of x. That is, you know what is a rational number. It will be of the form fractional form, where f of x and g of x are polynomials, function of x defined in the domain such that g of x not equal to 0. See, this is the graph of 1 by x and this is called a rational function. Here also, for different values of x, you will get different values of y. Suppose if you take f of x equal to y as y, So when you plot the graph, you will be getting different graph for different rational functions. Next, another important function is modulus function. What is modulus function? The real function f from R to R defined by f of x equal to mod x. It is defined as f of x minus x when less than 0 and x when greater than equal to 0. Now modulus means like this. You will represent it as x. For all values of less than 0 and greater than equal to 0, the value remains the same. For example, suppose minus 5. Modulus of minus 5 is also 5. Modulus of 5 is also 5. That is the modulus. Okay. Now the domain is on the real numbers and the range is because it takes all positive values including 0. It goes on till infinity. So only your range is 0, infinity. I think you have understood. That is modulus function, it takes only the positive values. So the range starts from 0 to, it is only this side, 0 to infinity. So your range is 0, infinity. Whatever number, suppose if you take my modulus of minus 10, it is 10. Modulus of minus 3, 3. Modulus of 4, it is 4 only. Next, we are going to learn signum function. Signum function is defined like this. F of x equal to 1 if x greater than 0, 0 if x equal to 0 and minus 1 if x less than 0. So what will you getting when you are plotting the graph? Here the graph is given. Now see the signum 1 if x greater than 0. Now for all values of x greater than 0, it is 1. That is from right hand side. So here you will be getting a hole like this. In your textbook it is written as a hole. So for all values of x greater than 0, from 0 is not included there. So from 0, that is without including 0, in the right hand side, that is all positive values, it is 1. For x equals 0, it is 0. And for x less than 0, 0 means here also 0 not included, it is minus 1. So the graph is drawn like this. What is the domain? Domain is your set of real numbers. What is the range? Range means it takes only 3 values, that is minus 1, 0, 1. So the range of this signum function is minus 1, 0, 1. Next is greatest integer function. What is greatest integer function? The real numbers, the real function f from R to R defined by f of x equal to this square bracket, that is the notation for greatest integer function. Assumes that the value of the greatest integer less than or equal to x is called the greatest integer function. Now see, it is defined like this. For x minus 1, if x is minus 1, it takes for minus 1 less than or equal to x less than 0. If it is 0, it is 0 less than or equal to x less than 1. If it is 1, it is 1 less than or equal to x less than 2. See the graph, the hole is here a set, but it should come here from, it is, the graph is given as 2, 4, 6, 8. See, if you take some values, for example, greatest integer function of 1 you will be getting as 1. That only it is written here because 1 comes here. Now when it comes to 2, it is 2, it jumps to this place. So till 1 point, that is greatest integer function of 1.75. that is also 1 only. Now when it comes to 2, it is 2, and till 3, that is 2.999, it will be 2. Then when it comes to 3, the greatest integer function will come to 3. That's why the graph is written like this. That is greatest integer function. For example, see here 1. 1 is included. So it comes to when 1.999 also the greatest integer function is 1 only. But when it comes to 2, it is 2. Greatest integer function of 2 will be 2 only. Okay. Next we are going to learn algebra of functions, that is how to add two real functions. That is very easy. That is, let f from x to r and g from x to r be any two real functions where x is a subset of r. We will define by f plus g from x to r. Then what is f plus g of x? F plus g of x equal to f of x plus g of x. Similarly, for subtraction of two real numbers, f minus g of x equal to f of x minus g of x. Now, if you are multiplying by a scalar, if alpha is a scalar, alpha f of x is alpha f of x. Now, for multiplication of two real functions, the product of two real functions is defined as fg of x equal to f of x into g of x. Similarly, for quotient of two real functions, f by g of x equal to f of x by g of x, provided g of x not equal to 0. So there are 4 types: addition, subtraction, multiplication by a scalar, multiplication of two real functions, and again quotient of two real functions. I will meet you in the next section. Thank you.